Hello and welcome to the presentation of our paper, Detection of Municipal Heat Plan Documents Using Semantic Recognition Methods. My name is Nicolas. I am a researcher at the Karlsruhe Institute of Technology, and I have the pleasure of presenting our results to you today. We start by giving a quick introduction or motivation to this topic. The German Act on Heat Planning and the Decarbonization of Heating Networks, which we will shorten down to Heat Planning Act, or for our German colleagues, the Wärmeplanungsgesetz, requires heat plans from municipalities with more than 100,000 inhabitants by the middle of 2026 and with less than 100,000 inhabitants by 2028. This means that, judging by the amount of municipalities in Germany, we can expect around 11,000 heat plans to be published by 2028. However, the Heat Planning Act does not require a central registration of these heat plans, so the municipalities can choose how and where to publish these heat plans. And in order to track which municipality has already provided a heat plan, and also to compare the different heat plans to another, so to find different goals, timelines, and in the end maybe even find synergies, and how these municipalities can be supported, a central search platform with a web crawler for heat plans is desired. To show how this can be achieved, we will show our planned procedure on a specific municipality. And we will assume that the municipality has already published their heat plan and that a search engine has already indexed the heat plan. We will then harvest said search engine, so for example Google, and we will blacklist known false positives. So for example, websites that look like they publish documents containing heat plans, but that are not actually containing heat plans. After that, we will download a set amount of candidate documents. And from these candidate documents, we will extract the document content. And based on the document content, we will do two things. We will A, recognize if the document is in fact a heat plan, or if this is some kind of other document. And B, we will recognize if this is the correct municipality. We will cover this topic more in depth later on. After that, we will enhance the document with more metadata and provide the data in form of an API and display it on a web interface. We will now show how the red items from the previous slide have been implemented, so how the candidate documents have been collected. In order to achieve this, we will assume that a search engine like Google has already indexed the heat plans and that they have been already published by the municipality. So to harvest them from the search engine, we will demonstrate this with Google and we will use the Google API. And our custom search query has two components. On the left in yellow, we see the search term, and this basically varies depending on the state that we are in. So for most of Germany, the translation for heat plan would be Kommunaler Wärmeplan, but there are some states like Bavaria where the translation could also be Energienutzungsplan or ENP in short. And the second component of our search query is the municipality on the right, marked in blue. And we get these municipalities from a dataset from the Federal Agency for Cartography and Geodesy. So they basically have a huge dataset which contains all the municipalities and also their district information and also federal information that you need to know. And also they contain area information and also IDs, so different municipalities which, for example, have the same name but are located in different places in Germany also have different IDs, so we can basically distinguish between them later. So from this search query, we now retrieve a lot of candidate documents for each municipality, but only very few of them are relevant for our specific topic. So in order to narrow it down a little bit, we apply some custom filter logic. This logic also includes a page limit because most of these heat plans that we were able to observe right now have way more than 100 pages. So for example, we limit the pages to at least 80 pages. Also the file type is very important because most of these heat plans are in PDF format. Then a date filter might also be applied because the law is very recent, so there will not be anything from before the 1st of January 2022, for example. and also that the source is not a domain that has been blacklisted judging by previous experience. And by applying this filter logic and also applying a limit, we can select at most 10 possible candidate documents for each municipality. We now have a pool of 10 documents at most for each municipality, which are candidate documents for heat plants, but we still don't know for sure which of these are genuine heat plants and which are not. So what we need to do now is we need to define two classes. One is genuine heat plants and the other is other documents. And we manually assign, just by looking at them, some examples to each of these two classes. And we now can take the examples from the genuine heat plant category and apply different techniques to it. For example, TF-IDF vectorization, which basically extracts the most frequent or most important terms from these genuine heat plants across the different heat plant documents. And from this, we produce a TF-IDF table, which contains these terms and also their TF-IDF value. We can now apply the same technique, so also TF-IDF vectorization, to the class of the other documents and also build a TF-IDF table there. And judging by also important terms from this category, we can subtract them from the class of the genuine heat plants, so that only terms that are exclusive or at least more important in the genuine heat plant category are remaining in this TF-IDF table. And with this, we can now use it to boost, for example, the importance of documents that contain these kind of terms, or even limit them if, for example, a document doesn't contain any of these terms, then we just say that we will omit these documents. From our pool of at most 10 candidate documents, we have now identified the documents with the highest probability of being a genuine heat plan. But this doesn't mean that we are done just yet. We are faced with two more challenges. One of them is identifying which of the municipalities this document is linked to. And this always happens if we have a municipality which shares a name with a different municipality. So two completely different entities in Germany with different spatial information, but they share a geographic name. And the way we do this is that we try to find other geographic entities, so toponyms, in the document and compare them to the possible municipalities for this document. For example, we find districts of this municipality or surrounding municipalities in the document content, and then we can just assign it to either one of these geographic entities. This is also called geoparsing or toponym resolution. And the other challenge could be that we have different documents, but with different dates. And our challenge now is to find out which of these documents is the most recent heat plan. The solution to do this is that we try to find keywords hinting towards the document creation time. So for example, from different text parts of the content of the document, and try to extract and normalize the temporal expressions from it and compare them across the different documents. This task, so the normalization, is also called time expression normalization. We've also tried to evaluate our whole process, but the issue at the moment is that we don't really have a lot of heat plants available in Germany because this is a very recent law and there is still a huge deadline. So at least 2 more years for the municipalities with over 100,000 inhabitants and even 4 more years for the ones with less than 100,000 inhabitants. So we've only been able to build a small evaluation dataset of 10 genuine heat plants and 19 other documents. And from what we've seen is that 28 of these 29 documents were associated with the correct municipality. 29 of 29, so all of them, were assigned with a meaningful date, meaning that we were able to identify the most recent one, but this wasn't also this important because there were not a lot of different heat plants at the moment. And 9 of these 10 genuine heat plants were ranked on top. Then there have been like some other documents, and after that came the last genuine heat plan. So this means that our boosting with the TF-IDF vectorization in theory works, but it could still be better, and of course we need to evaluate it if we have more heat plants available. Unfortunately, we are not able to provide results for the geoparsing model for the German language, as there is no competition for it, and also very few for the English language. But we are at least able to provide an evaluation for the normalization of the temporal expressions, as there's a lot of competition for it for the English language, and at least some for the German language. For English, we can see the results on the left side. On the left are the models, and on the top, so the columns, are different data sets. And we provide the results for TemperVal3 and TweetsM, which are both very frequented data sets for this task. And we can see that our model, KitTime on the very bottom, performs just like other models, or even outperforms them on some tasks. And on the right, we can see on the top the results on the Krauts dataset, which is a German dataset. And only Heideltime has provided their results for their model before us. And we can see that our model outperforms them on the German language. And on the bottom, we have also created our own dataset, but this will be published in a different publication in the near future. But we can see that we also produce very good results for it. To summarize this presentation, we can say that the German Heat Planning Act will probably result in around 11,000 municipal heat plan documents, and that we've already prepared a central location where the heat plans can be made available or can be shown. The evaluation of the recognition of heat plans could be more significant. However, we are unable to do so at the very moment because there are just not more heat plans that we can evaluate ourselves on. But the methods that we have used have also been applied in other use cases and have also proven themselves there. So there's a high possibility that this will also apply in the very future. But of course, we will repeat the evaluation once more documents are available. For the evaluation on temporal expression normalization, we can say that we are able to compete with state-of-the-art models. And this means that we can ensure that always the most recent heat plans are selected, or at least most of the times, of course. And our methodology can be adapted for other use cases and also countries. Of course, this means that, for example, language resources have to be translated, and, for example, other reference datasets need to be used. That is everything from our side. I would like to thank you for your attention, and if you want to get in touch and want to talk about this topic or other topics related to the ones that we've shown in this presentation, then feel free to contact me. I wish you a very pleasant remaining stay at the EnergyInformatics.Academy. Hope you hear some interesting presentations, and after the conference, please have a safe travel back home. Thank you very much.